Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So we're doing this one question at a time. Here's question 1. The Hot and Tasty coffee chain conducts a survey of its customers at its location at the Staten Island Ferry Terminal. After the survey is completed, the statistical consultant states that 70% of customers who took the survey said that most important factor in choosing where to get their coffee is how fast they are served. Based on this, Hot and Tasty coffee can infer that. Let's look at each answer choice and see what makes the most sense. 1. Most of its customers in New York State care most about being served quickly. Being served quickly is right, but New York State does not sound right because we're just talking about the Staten Island Ferry here. Coffee drinkers care less about taste and more about being served quickly. This is all coffee drinkers, so this is including way too many people. We just want people from the Staten Island Ferry Terminal. And choice number 3. Most of its customers at the Staten Island Ferry Terminal care most about being served quickly. So here we have Staten Island Ferry Terminal and how fast they're being served. So this is the answer, choice 3. Question number 2. Given that I is the imaginary unit, the expression x minus 2i squared is equivalent to, so let's just expand this, x minus 2i times x minus 2i. So we're just going to multiply and distribute each term to each other. X times x gives us x squared. X first outer, so x times minus 2i, we get x minus 2xi. And then inside we get minus 2i times x. So we get minus 2xi again, and then minus 2i times minus 2y will give us plus 4i squared. So now we just want to combine like terms, which is minus 2xi, which gives us minus 4xi. And this 4i squared, the I squared can become negative 1. So when we do that, we get minus 4. And if we look at the answer choices, the only one equal to this is choice 4. Question number 3. The equation below can be used to model the height of a tide in feet, h of t on a beach at t hours. So we have this long trigonometric equation here. Using this function, the amplitude of the tide is, so the amplitude right here is always going to be this number right next to trig function on the left, which in this case is 4.8. Choice number 2. Question number 4. In watching auditions for lead singer in a band, Liam became curious as to whether there is an association between how animated the lead singer is and the amount of applause from the audience. He decided to watch each singer and rate the singer on a scale of 1 to 5, where 1 is the least animated and 5 is the most animated. He did this for all 5 nights of auditions and found that the more animated singers did receive louder applause. The study Liam conducted would be described as, so just looking at these, we have experimental, observational, sample, survey, and random assignment. So the one that makes most sense here is observational because Liam isn't experimenting on anything, but what he is doing is using his own observations. So this is, the answer here is choice 2. Question number 5. In the diagram of a unit circle below, point A has this value, negative. What is angle theta? So I'm going to redraw this over here with our point. So remember, the thing about trigonometric graphs is that a point like this can be written as cosine of theta, sine of theta. So what this means is that cosine of theta is equal to negative 3 over 2. So we know that this is going to be some angle. So we're going to be trying to find this angle over here so we can figure out what this is. So what this means is cosine of theta is equal to rad 3 over 2, but we don't know what the angle is. So, and it also means sine of some angle is equal to 1/2. So to do that, I'm just going to make sure I'm in degree mode on the calculator and then go second sine 1/2. So you can use cosine too, but I just chose 1/2 because it's easier. So we see that this missing side here is 30 degrees. So remember, this whole quadrant is equal to 90 degrees though, right? This is 0 degrees, 90 degrees, 180, and 270. So we know that 60 degrees is going to go here. So if we know that this is 60 degrees over here, if we go back to that original graph they gave us, and we know that this whole section is 90 degrees, we could just add them together. 90 degrees plus 60 degrees, which gives us 150, which is choice number 4. Question number 6. Consider the function f of x is equal to 2x cubed plus x squared minus 18x minus 9. Which statement is true? So it looks like they're looking for the factors of this right here. So you can plug this into your calculator, or you can realize that it can be factored by using factor by grouping. So let's use that. So here, to factor by grouping, we're going to separate into groups, and then we're just going to take the GCF of each group. So over here we'll take the GCF, which in this case is x squared. We're left with x plus 1, 2x plus 1. And then over here, the GCF is going to be 9. And then we get the same thing, 2x plus 1. And you want these to always match and be the same thing. So now we're going to combine the numbers outside, x squared minus 9, and then the matching values, 2x plus 1. And notice this can be factored even more by difference of two squares, x plus 3, x minus 3, and then just bringing that down, that 2x plus 1. So now we can go back and look at our factors and see which applies. So 2x minus 1, no. X minus 3 is a factor of f of x. Yes. So the answer here is choice number 2. Question number 7. Which sketch could represent the function m of x equals negative log base 100 x minus 2 of x minus 2? So I'm going to do this one step at a time by doing transformations to the graph log of 100, log base 100 of x. So what this looks like, so taking away, so notice we have, this is a negative log base 100 of x minus 2. So let's just kind of erase the negative sign and the minus 2 and start with this and see what this looks like. So if you plug this into your calculator, you'll get something that looks like this. So this isn't what we're looking for though, right? Because that kind of looks like number 3, but this isn't what we're looking for. So next, when we add a minus sign, minus log base 100 of x, it's going to look something like this. So now we're going to be flipping it. So since it's a minus sign of the whole thing, we're going to flip it upside down. And it's going to be a reflection. So when we do that, it's going to look something like this. So that's very close to number 4, but let's go ahead and transform it one more time to include that minus 2. So we have minus log base 100 of x minus 2. So now since it's minus 2, we're just going to do the same thing, but now we're going to bring over our graph 2 units to the right. So it's just going to be a little more to the right than it was before. So we're looking for an answer, which is choice 4. Okay, question number 8. Which equation has roots of 3 plus I and 3 minus I? So let's use the quadratic equation here, and let's just go one by one. So let's start with choice 1 here. And I have a video on how to do this quadratic formula, if you want to check that out. So, okay, so we just got to fill this in. So minus b will just be 6 plus or minus b squared, which is 36 minus 4ac all over 2a. So the first step into figuring out what this is just, first let's calculate what's under the radical. So it's 36 minus 4 times 1 times 10. And we get 6 plus or minus negative 4 all over 2. So remember, we can't have a minus 4. 6 plus or minus, this becomes 6 plus or minus 2i all over 2. And then from here we can branch this out into 3 plus I and 3 minus I. And these are the roots of this equation, which is actually what they were asking for, so choice 1 is our answer. So we got lucky, we didn't have to do the quadratic formula for any other. Question number 9. A local university has a current enrollment of 12,000 students. The enrollment is increasing continuously at a rate of 2.5% each year. Which logarithm is equal to the number of years it will take for the population to increase to 15,000 students? So the formula that comes to my mind is the PERT formula, P times e to the RT. So where P is the principal. So that's the amount we're starting with, which in this case is 12,000. E is a constant, so we don't have to plug anything in there. R is the rate, which in this case is 2.5% or 0.025. And then T is what we're trying to find, the time in years, which we don't know. And A, they give us, because we want to know how much 12,000, how many years 12,000 becomes 15,000. So 15,000 is A. So now we can just plug this in. So we have 15,000 is equal to the principal, 12,000, times E to the RT, 0.025T. And then we just need to solve for T using ln logarithms. So the first thing I'm going to want to do is just divide out this whole number, 12,000. We don't even need to solve it all the way, we just need to get it in a certain format and we'll get the answer. So 15,000 divided by 12,000 gives us 1.25. So 1.25 is equal to E raised to the 0.025T. So now we're going to be using ln since we have E, because ln has a base of E. So in this case, we just have to think a little backwards. So E raised to the 0.025T is equal to 1.25. So to rewrite that, we're just going to say that ln of 1.25 is equal to 0.025T. And you can check yourself knowing there's a little E here and see that E to the 0.025T is equal to 1.25. And since we're trying to find T, we're just going to divide out 0.025. So now we won't even have to solve it all the way, so we just want to look for T is equal to ln 1.25 over 0.025. So there are a lot of similar ones, there's some similar ones here. This was similar, so just be careful with that. This has the 0.025 that we want, so this is our answer, choice 4. Question number 10. What is the total number of points of intersection of the graphs of the equations y equals e to the x and xy equals 20? So let's just plug this into our calculator and see where these two functions intersect. So we have e to the x, and then we also have xy equals 20. So we want to get this into y equals form, so we're just going to divide out this x. So we get y equals 20 over x. So we'll hit graph, and you'll see that we have y e to the x, which looks like this right here. And I didn't graph them separately, but if you did one at a time, you would know that 20 over x is these two over here. So you can see that they intersect at one point, choice 1. And that's our answer. Question 11. The amount of a substance A of t in grams remaining after t days is modeled by A of t equals 50 times 0.5 raised to the t over 3. Which statement is false? So we're looking for something that is not true. So let's look at answer choice number 1. It says, in 20 days there is no substance remaining. So again, we're going to want to plug this into our calculator so we can just easily look for different answers. So let's plug this in. Okay, we go to second table, and we are going to scroll down to 20 days. So this T represents days, or X in this case. So we're just going to scroll down to 20 days. And you'll see that we have this value about 0.5, right? There's 0.5 substance, 0.5 of a substance remaining. There's no substance. So this is false. There's 0.49 of this substance. So choice 1 is our answer. So that was an easy one. It just worked out that the choice 1 was false. Question 12. A parabola that has a vertex at 2, 1 and a focus at 2, -3 has an equation of what? So let's sketch out what we have here. So if we have the vertex is at 2, 1, and then the focus is 2 -3. So the thing about the focus is that it is a point that is always on the inside of the parabola. So the parabola is always going to be hugging kind of the focus. So we know that our parabola is going to be facing this way because the focus will have to go inside. So because it's facing downwards, we know that our parabola is going to be negative. So if we know it must be negative, we know we can eliminate choice number 1, and the rest are all negative. But now the vertex is 2, 1. So the only choice that makes sense here is choice number 3. So just a little reminder about vertex form of a parabola. What that looks like. It looks something like this, where the vertex is equal to h comma k. So notice we negate the h but not the k, which is exactly what we do here. We negated the 2 but not the 1. So choice 3 is our answer. Question 13. A times the cubed root of 2b squared times the cubed root of 4a squared b is equal to what? Both of these terms have the cubed root. We can just multiply everything together. So we're going to have the a on the outside, and then we'll have to the cubed root, going to keep that the same. And then we could just multiply the inside as normal. So 2 times 4 is 8. There's only a squared on this side, and then b squared times b. You could just add the exponents. So now we need to ask ourselves, can we take the cubed root of any of these terms inside? So, and the answer is yes, we can. So the cubed root of 8. So you can either plug this in on your calculator, or you can realize that 2 times 2 times 2 is going to give us 8. So we can take out a 2a. And then this a here, can we take the cubed root of that? No, right? Because there's an a squared there. We can't divide this exponent by 3 evenly. Now what about the b cubed? The cubed root of b cubed would just be b, right? Because b times b times b would just be b cubed. So we could take that b out. So what are we left with? We have 2ab times the cubed root of a squared, which is choice 1. On to question 14. Given f of x equals 3 to the x minus 1 plus 2 as x approaches negative infinity. So we have a limit question here. So let's graph this on our calculator. Let's see what happens to those y values as x is approaching negative infinity. So 3 raised to the x minus 1 plus 2. And let's see what that looks like. So it looks something like this. So if we look at the table and start going to the negative values, what we want to know what y is doing as x is going more and more negative. So let's go to the negative x values. So see how we keep going up and getting more and more negative. And notice y is just at 2, right? So as x is approaching infinity and is going this way, We get closer and closer, and eventually we just become the number 2. So the answer is choice 3. Question 15. For all values of x for which the expression is defined, x squared plus 3x over x squared plus 5x plus 6 is equivalent to what? So here we're just going to factor a little bit. So x squared plus 3x, we can take out a GCF of x, and there we'll get x plus 3. And over here, this trinomial, we can do the product sum, where we get 2 and 3, so we give x plus 2 times x plus 3. Notice we can cancel out these x plus 3's, and we're left with x over x plus 2, which is choice 2. Question 16. A recursive formula for the sequence 64, 48, 36 is. So let's see what this pattern is. I'm just going to write it bigger over here. So let's see how we get 48 divided by 64. So it looks like we're multiplying times 0.75 or 3/4. Either way you want to see that. Now let's just double check 36 divided by 48. And we get 0.75 again, so times 0.75. So we're going to be looking for something that resembles a geometric sequence with a common ratio of 0.75. We're also going to make sure that the first term is equal to 64, which they gave us. So if you look at the first answer choice and the third answer choice, these aren't actually in recursive formula format, so we know that those are not the answer. And now choice 2 and choice 4 have that first term 64, but if you look at choice 2, this is an arithmetic sequence. So we know that that's not our answer. And you can see that 0.75 times the previous term, this is going to be our answer. This follows the pattern. And if you wanted to do the pattern and fill it out, we have the first term is 64, and then we have 0.75 times the previous term, which is 64. And when you do that, you'll get 48. And then the third term, 0.75 times 48. So we're just plugging in the previous term, and you get 36. And then the pattern can keep going. So we know our answer is choice number 4. Question 17. Which expression is equivalent to x cubed minus 2 over x minus 2? So here we're going to use a little division, log division. So let's rewrite it over here. So we're going to have x cubed. So instead of just writing x minus 2, we're going to write out any missing value exponents that are missing. So we're going to have 0x squared, so x cubed plus 0x squared plus 0x, and then put in that minus 2. So these are just placeholders that will make it easier for us to divide. So now let's put in what we're dividing by over here, x minus 2, and then just look at this one by one. So how many times can x go into x cubed? So that would be x squared times. So x squared times x gives us x cubed. And then x squared times minus 2 will give us minus 2x squared. And we subtract 0 minus negative 2x. We have a double minus here. Will just give us 2x squared. And then we could just bring down the rest of what's here. Plus 0x minus 2. And now we need to ask ourselves, how many times can x minus 2 go into 2x squared plus 0x minus 2? And we can see that it can go in 2x times. So now we're going to multiply 2x times x. It is 2x squared, and then 2x times minus 2, which gives us minus 4x. So these cancel out, and we have 0 minus negative 4, which will give us a positive 4x, and then we could just bring down this minus 2. So now we're on our last little group here to see how many times x minus 2 can go into 4x minus 2, and that will be 4 times. 4 times x is 4x, And 4 times minus 2 is minus 8. Subtract 4 minus 4x is 0. And then negative 2 minus negative 8 is going to be 6. So we get x squared plus 2x plus 4, and then we have a remainder of 6 over what we were dividing by, x minus 2. So if we look up at our answer choices, this matches perfectly with choice number 2. So I have a bunch of questions on how to divide polynomials, so please check that out. There's also another method with using synthetic division, so I have a video on that also. Question number 18. What is the solution set of the equation? And then it gives this long equation. So notice right away we can factor this using product sum. We get minus 2 and minus 6. So we can rewrite this denominator as k minus 2 times k minus 6. And notice that's the denominators we have here. So we can write this as k minus 6 to get the same denominator. So we have k minus 2 already, so we need a k minus 6, so we can make this k minus 2 times k minus 6. And then the same idea over here, we're just going to multiply the numerator and denominator by k minus 2, the binomial that's missing. And then because they're all the same denominators, we can actually cancel them out and just ignore them. So we have 4 is equal to k times k minus 6 plus k minus 2 times 1. So I'm just going to make it k minus 2. So I'm just going to distribute this k. And then we can combine like terms. So we have k squared negative 6k plus k will give us minus 5k minus 2. We still have this 4 out here. We can bring that inside. So we get 0 equals k squared minus 5k minus 6. So now that it's set equal to 0, we can factor this. So we have p equals negative 6, sum equals negative 5, and we get minus 6 and positive 1. So we have k plus 1 and k minus 6 is equal to 0. So this gives us k equals negative 1 and k equals 6. So before we get too excited and say that these are our solutions, both of them, just since we had fractions in the denominator, we have to make sure that none of them will be equal to 0. So if you look here back at our original equation, if k were equal to 2, so k can't equal 2 or it would be 0, and k can't equal 6, right? Because then they would 0 out. So if you look here, we have a k equals 6. We know we have to reject this, and our only answer choice is k equals negative 1. Oh, I just made it hard to see. That's a negative 1. So our answer choice is choice 3. And that's our answer. Let's look at question 19. Given the polynomial identity, and we have this long identity, which equation must also be true for all values of x and y? So here they already have x to the 6 plus y to the 6, which is what we were working with, all written in different ways, but all of the left side of the equation looks right. So we have to make sure that the right side of the equation looks right by multiplying and distributing and adding and subtracting and doing everything we need to do PEMDAS to see if it's correct. So let's just start and check if choice 1 is right. So they're saying x to the 6 plus y to the 6 equals this whole thing. So let's see. So let's distribute this x squared. And then, so this is all of x, and now let's distribute the same thing with y on this side. So now we need to combine like terms. So we have x to the 6th, there's no other x to the 6th, so that's going to come down. Then we have this minus x to the 4th y squared. And if you look over here, we have a positive x to the fourth y squared. So these are actually going to cancel out. And then next we have this term x squared y to the fourth plus, and on this side it's minus x squared to the y fourth. So these are going to cancel out too. And then the only thing we're left with is y to the sixth. So this matches with what we were trying to prove, that identity, so we know choice 1 is our answer. And if you checked out other answer choices, it wouldn't match up. Question 20. Given p of theta is equal to 3 sine of 1/2 of theta on the interval negative pi to pi, the function p, and then we need to describe whether it's increasing, decreasing, one or the other, or both. Okay, so let's look at this trig function. So first let's identify the different parts of this trig function. So we have the amplitude, which is equal to 3, which is kind of like the height of the graph. So let's graph it out while we're doing this too. So in this case it goes up to 3. It's sine, which, just a reminder what sine looks like. It has that S shape, something like that. Just a little note. Okay. Up next we have this 1/2 of theta. So just a reminder what this represents, this is the frequency, the number of cycles that happen between 0 and 2 pi. Which in this case is half a cycle. So this is one cycle right here of sine. But that goes up to 2 pi, but we're gonna be doing a half a cycle and only going up to pi in this question. So something we're gonna need to find in order to do that is the period, which is the length of a cycle. And to find that, we just do 2 pi and then divide it by the absolute value of the frequency, which in this case is 1/2, which will give us 4 pi. So that means it takes, for one cycle to happen, in this case one cycle of sine, this is going to go up to 4 pi. This is 2 pi. So we're going to be counting by pi basically. But we don't even have to go all the way up to 4 pi. What they're asking for is what happens between negative pi and pi. So if we know we're working with a sine curve, we know we're going to start at 0, 0, and then the next coordinate, since we're going by pi, we're just going to be going up to the next coordinate point all the way up to 3. And then in the opposite direction for negative pi, we're going to be going down. And when you look at what this graph is doing, it's increasing the whole time. So the answer here is increases throughout the interval, because this is the only interval from negative pi to pi that they care about. So just so the question makes sense, just so this graph makes sense, if you were to graph the one whole cycle, it would go all the way, it would take all the way up to 4 pi, and you'd be counting by pi. And it would look something like that. Question 21. A company fired several employees in order to save money. The amount of money the company saved per year over 5 years following the loss of employees is shown in the table below. Which expression determines the total amount of money saved by the company over 5 years? So let's check out what's going on in this table and look at the relationship between these numbers. So I'm going to start by dividing them, because I think this is going to be a geometric sequence. So 64,900 divided by 59,000 is 1.1. And let's double check. Let's check out the next pair of numbers. 71,390 divided by 64,900, also 1.1. So we're multiplying times 1.1 for each year. And this is the savings that this company is having by firing employees. Okay, so we know we have a geometric sequence, but they want to know the total amount of money saved. So that means they're going to want to sum all these numbers together, which actually is going to give us a geometric series. So the geometric series formula looks something like this, where the first term is a sub 1, which in this case is 59,000. R is the common ratio, which we found is 1.1. And then N is the total number of years, which they gave us, which is 5 years. And now we just need to plug this in. So S sub N equals 59,000, that first term, times 1 minus the common ratio, 1.1, raised to the 5th power, to the N, all over 1 minus the common ratio, 1.1. So if you look at our answer choices, there's nothing that exactly matches, but what they did here, which is could be a little tricky, is that they distributed the 59,000. So if you realize that, then this should be an easy question. So if you distribute 59,000 times 1 minus 59,000 times 1.1 raised to the 5th power, all over 1 minus 1.1, you'll see that we have this, choice 1. So a little tricky to remember the formula in the first place and then to realize that they distributed it, but this is our answer. Question 22. A rush hour commuter train has arrived on the time 64 of its first 80 days. As arrivals continue, which equation can be used to find x, the number of consecutive days that the train must arrive on schedule to raise its on-time performance rate to 90%. So x is going to be equal to the number of consecutive days. And we're going to need this rate, number of consecutive days of the train arriving on time, to be up to 90%. So we have 64 days already where it's on time, but we're going to be measuring more days. We don't know how many more consecutive days over. This was 80 days in the first 80 days, but how many? This was the first 80 days, but we're going to be adding more consecutive days. So basically we're adding days to the numerator and the denominator because we're going to need them to be on time. The number of consecutive days that are on time. And we have to set it equal to the performance rate of 90%, which is just easy. That's just going to be 90 over 100. So look for our answer choice, and it's choice number 2. So it's like a weird kind of problem, but it shouldn't be hard. Question 23. Given f of x is equal to negative 2/5 x plus 4, which statement is true of the inverse function? So to find the inverse of any function, what we're going to do is, so first let's start with our function that we're given. And we're going to flip the x and y. So here was y, now it's going to be x. And here is x, and now we're going to put y. And now we're going to solve for y. So this is our inverse function, and now we just need to see which of the statements is true. So it says that the slope is 5/2, we have negative 5/2, so that's not right. The slope is 2/5, that's not right. Passes through the point 6, negative 5. So there's different ways you can do this. You can plug this on your calculator, or you could just quickly plug it into the equation and see if it's true. And in this case it's true. So we know that 3 is correct. The inverse of f of x passes through the point 6, negative 5. And that's our answer. Question 24. The amount of a substance A of t that remains after t days can be given by the equation that they have here, where A sub-0 represents the initial amount of the substance. An equivalent form of this equation is, and then we need to figure it out. So I'm just going to rewrite it down here first. So if we were to plug in, so this is like a bit of like playing around with the numbers. If we were to plug in 1 for t, let's see what we would get. So we get something like this, 0.00, oh, sorry, another 0, 0.0001781, and it just keeps going. So technically, if we rewrote this as a sub 0.000178 raised to the t, we would get the same answer as we would here. So they do have this answer as choice number 1. So that's our answer. That takes a little playing around with the calculator and playing around with the formula to figure that one out. So this is the end of part 1. I hope you found these questions helpful. Please let me know if you have any questions in the comments below, and look out for part 2 coming out soon. Happy calculate! So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!